More than 6 women become pregnant each second around the world. Of those not resulting in miscarriage, about 2 or 3% result in a baby with a congenital malformation. Monitoring the health and condition of the developing fetus is one of the most significant pregnancy-related costs. Currently, several techniques are available for the screening and diagnosis of chromosomal anomalies, which, however, account for less than 50% of all congenital defects. For other malformations, which are currently mainly diagnosed in more advanced stages of pregnancy by ultrasound evaluations, no screening test is available. In the light of the above, in this multi-center observational retrospective study, we describe a novel and non-invasive approach based on metabolomic profiling for a comprehensive screening of fetal malformations. Metabolomics is an emerging omics technology, which studies the metabolome, defined as the set of metabolites contained in a biological systems. As the metabolites are the final products of the omics cascade, they reflect both the information contained in the genetic code and the influences derived from the interaction with the environment. Therefore, metabolomics is considered the omic science closest to the phenotypic expression and opens new perspectives to the study of the mechanisms underlying the various pathological conditions, as well as to the development of novel diagnostic and screening systems in which the metabolome, as a whole, can be used as a biomarker. In the first stage of the study, a total of 654 Italian pregnant women were enrolled and used as a testing cohort to build an ensemble machine learning classification model based on serum metabolomics profiles. The pie graph shows the anomalies distribution in the training testing cohort. This is the pipeline we have followed. Samples were collected between 18 to 22 weeks gestation. Metabolites were quantitatively extracted, purified and analyzed by gas chromatography mass spectrometry. The data obtained were pre-treated, normalized, scaled and so on, and used to train several classification models, which were then ensembled in a unique classification system. That is a screening test able to recognize a blood sample as coming from a woman with a healthy or malformed fetus. Indeed, each classification model is a mathematical algorithm that, as such, is prone to make errors based on its operation. Combining different models into a single ensemble machine learning tool allows minimizing those errors, thus achieving significantly higher diagnostic performance than individual classification models. In our case, 9 individual classification models were constructed and then combined with a voting system, in which each vote had a different weight, evaluated by means of the model's accuracy. As a result, the ensemble resulted in 100% accuracy. However, to be sure of the reliability of the test under different conditions, we decided to test it on a different and much larger population, with a completely different genetic and dietary input and, most importantly, under real blind conditions. In the second stage of the study, samples from the New Zealand cohort of the International Scope Study Biobank were used to validate the classification system. A total of 1935 second trimester maternal serum samples were blind analyzed and used to independently test the trained classification models. Upon revealing the blind, this inexpensive and non-invasive screening system showed excellent accuracy, greater than 99%, resulting from relatively few false positives and false negatives. Accuracy was not dependent on the type of malformation. Indeed, among the various classes the score reported values above the cutoff used. The study of metabolomic alterations associated with fetal malformations also allowed us to identify the metabolites of greatest interest involved in this condition. This could provide new insights into the mechanisms underlying the development of these abnormalities. In conclusion, the present study provides a clinical validation of a metabolomics-based prenatal screening test to detect the presence of congenital defects. Further investigations are needed in order to enable the identification of the type of malformation as well as to confirm these findings on even larger study populations. Thank you for your attention.